So today I'm going to talk about the co-benefits of energy saving and air quality in building retrofits. I myself is mainly working on air quality, but thanks to Dr. Lee and Danny Yip, so I have the opportunity also to look at the energy and the building retrofit. So to identify what is the co-benefits that resides in the building retrofit. Well, there are some research in other places give us some experience. You see, there are some measures identified by previous studies in different places. It's showing some of the measures may improve the energy performance. Some of the measures will reduce the indoor pollutants. And a lot of the identified can be help with the energy performance as well as the indoor air quality. But the question is, all these measures are identified in other places. Which strategy are useful for Hong Kong? To answer this question, we need to know what is the outdoor climate we have in this region. And we need to understand what is the characteristic of the outdoor pollution we need to deal. So in Hong Kong, we have very hot and humid climate. So that's a big problem that HVAC system need to deal with, the temperature and humidity thing. Now also we have a concern on outdoor air pollution, and specifically we have a seasonal variation that the outdoor pollution differ substantially between summer and winter. Also, the land in Hong Kong is very expensive. If we have a very large equipment for the retrofit, that's not acceptable. And also economic aspects for the payback period. But what we can show here is a case study that we identify some of the measures work together can have co-benefits on energy as well as the indoor environment. We summarize our work and publish in an international journal called Energy and Buildings. And here is the major findings. We found the retrofit HVAC system in the study building can save energy up to 50%, while maintain an acceptable thermal comfort and indoor air quality that complied with international guidelines. And the payback period is 3.5 years. How can this project achieve that? So let's look at the project details. So this is a building that owned by TAL. It's built in 1975, have 16 floors. It takes the air from the roof and use a central ventilation and use a chill water for cooling. So what have they retrofit on the HVAC system? First, they add a two-stage filtration system for particles. Previously, they have a filter that made of aluminum mesh, but now they added a pleated filter that have a minimum efficiency recall value MERV 13 scale. And that pleated filter can have the capacity to filter out the fine particles. So this is how it looks like. The air is going from the right-hand side to the left-hand side, and it goes through the aluminum filter to filter out the coarse particles, and then go through the pleated filter for the fine particles. They also deal with the humidity issue. They have a specially designed cooling coil to dehumidify the fresh air so that the air will be dried before they come into the indoor. Let's see, this is a demonstration showing the outdoor moistured air. After they're going through the filters, they will go through the specially designed coils to dehumidify the fresh air. So after this device, the dry air will be provided to the indoor place. And they also add a split PHU on 5th floor for enhanced ventilation. And the reason why they do that is they have a showroom on that floor, which hold event from time to time. To provide proper ventilation, they add air intake just outside the window so that they can give sufficient ventilation when there is a crowd. Well, the first part is they build up a building management system to monitor and control the ventilation and the air conditioning. And this is one of the beauty of this system is they have the sensors indoors to check what is the CO2 level. And based on that, they will control the system to adjust the airflow of the fresh air so that when there is a lot of people, they increase the ventilation. When there is not that many people, and there's not the big need for the ventilation to decrease the airflow. But that they can provide proper ventilation as well as safe energy. So this is how the device look like. Last but not least, they maintain a positive pressure. Why positive pressure matters? They help to prevent the infiltration of outdoor humidity and pollutants from the building envelope. That is, they constrain all the air just come from the major air intake of the ventilation system. They renovate the building envelope and they adjust the flow rate to make sure that the indoor pressure is higher than the outdoor. And this is confirmed by our measurements. The outdoor pressure is lower than the indoor. So by doing that, they maintain a positive pressure successfully. So up to this point, these are all the work that has done by TAL and Danny Yip. So my work comes in at this point. So we comes in to assess the performance of the system. We're assessing 3 parts: the energy part, the indoor environment part, and the cost of benefit analysis. Overall, it can save energy up to 50%, lead to an annual energy saving of about 700,000 kilowatts hour per year. For the indoor environment measurement, we put sensors in the office area that people work. We also put sensors at the rooftop as a basis for the evaluation. So we have simultaneous measurements, both indoor and outdoor, so that we can know whether the indoor air quality maintains a good status while the outdoor changes. For the thermal comfort, PMV has 7 categories. The blue framed area is regarded as acceptable thermal environment for general comfort that's recommended by ASHRAE standard 55. So this is our measurement showing how many percentage of the hours during the measurements that fall in this area. And you can see in winter, all the hours fall in that comfortable zone. And in summer, about 90% of the hours fall in the comfortable zone. So we can conclude that the current HVAC system can achieve a generally acceptable thermal comfort. Well, for air quality, we use 2 standards. One is from the local government, the Hong Kong Indoor Air Quality Guideline, and the other is international, it's from the WHO. It's showing the measurements of a PM10 concentration in both winter and summer. And you can see the red shaded area is the outdoor concentration. And if you look at the indoor concentration we measure in that building, that's substantially lower than what we see outdoor. If you draw a line, it's complied with the excellent class in Hong Kong IAQ and also comply with the WHO annual guideline. So it's very good. And this also happened to PM 2.5. What's the role that the added pleated filter play in this system? So we do an experiment. So really the pleated filter play a very important role in protecting the occupants in the building from the pollution of the fine particle and of course the coarse particle in the outdoor environment. So let's summarize. At this point, we have a win-win situation on energy and the environment by retrofitting HVAC system. The next question would be, wow, this is really a very excellent system, but how much we need to pay? Let's look at the cost. The initial investment is 2.4 million Hong Kong dollars. And the pleated filter they need to replace every 3 months will cost about 60,000 Hong Kong dollar per year. And the benefit directly from the energy saving is this much. If we subtract the replacement of the pleated filter, we'll get a net return every year is about 720,000 Hong Kong dollar per year. And if you divide this number by the initial investment, that will give you the payback period is about 3.5 years. That's very good. Which is even better, and we haven't included in our analysis, is the environmental benefits. So with the improved indoor environment, you will reduce the health risk of the occupants, reduce the sick leave, the medical care cost, but at the same time, improve the working performance and improve the sustainable economy. And I believe this is much higher than what we can gain from the energy part, if not an order of magnitude. And also, when we think about the building sector, we also think, oh, it's consume a lot of energy, it's contribute to the air pollution. But have you think about building can also purifying the outdoor air pollution in your city? If you look at this demogration graph, you can see the air going out from outside, going through the system and go back to the outside. So the building with the particle filter serve as an air purifier in the city. And for the test building, the PM 2.5 infiltration is 40%, which means the building can filter out 6% of the particles. And it has a capacity of 25 million cubic meter per year. So this air purifier has benefit a lot to the surrounding environments as well. Think about we have 9,000 high-rise buildings in Hong Kong, of which 1,000 are commercial buildings. So there are great potential for building to help clean the city. Well, since most of the audience are from the engineer part, let me ask you a question. What if we got more buildings like this? What energy saving potential we can have for Hong Kong? I just do a simple calculation, so it should have some uncertainty there, but just give you a sense. So according to the final energy use, HVAC system will take account 10% of the final energy use. And the retrofit of this study can achieve 50% energy saving. Well, this is an old building. We just make a conservative assumption that most of the building may not have that. Then we take an average, we reduce 50%. We just assume on average only 25% can achieve. But even that, when we multiply these two numbers, we can save about 2.5% of the final energy use in Hong Kong, or 7,000 terajoule. And this is not a small number if you compare to the electricity consumption in industrial and domestic. So I think there is a great potential to use on this HVAC system for energy saving in our society. Finally, I would like to share some of my thoughts in this project. So most of the people care about the energy, and that is a very important thing. But if we just take a step further to also consider the environment, then we can do a lot of things, because the environment is much more related to people. And from this project, and that can not only save energy, but also do good to the occupants. And when it do good to the occupants, and we can include a lot of people and increase the incentive from different sectors, so it makes things more possible to be done to safeguard our society. So when we think about things, we are so habituated to just thinking in our own areas. But how about to think it's not beyond what we are just looking into? We also look at other things, so that we can think coherently, we can collaborate others, and then we can have co-benefits. Well, for this study, I really want to thank Dr. Lee for his full support to grant us the access to do all these studies in his building, and also Mr. Danny Yip, who provide a lot of technical details for us to understand why. And the measurement is supported by Praise HK, the project Praise HK, which is a 5-year project that empower the public to know the air quality in their daily life. And the original paper can be downloaded at the link I given, and there are also policy report that link to that paper you can download from Institute for the Environment, and also a report from the World Green Building Council. With that, I would like to thank you all and be glad to take any questions. Thank you.
已經想問下 Dr. Lee 你啦嚇，即係你喺運作呢個服裝界嘅工作，但係咧又咁有心去將自己成棟 building 去做一個翻新工程。你當初嗰個理念或者願景係點樣？而家嗰個運作你滿唔滿意咧？有冇啲挑戰同埋係經驗可以同我哋分享嘅？
運作就好穩定，好穩定。呢個成個 project 開始喺我屋企開始，一路喺度改進啦。我諗已經第6、第7代嗰個係好慳能源嘅。我每個月嚟嘅電表即個電單我就知嘅。如果嗰啲能源可以慳25%咧，全香港嘅電就可以慳到2.5%。我最大嘅理想咧就係點樣可以對呢個環保方面可以有啲貢獻。我覺得呢樣嘢，如果大家肯即係去諗點樣可以安分落依家嘅 building， 或者尤其係如果新起嘅大廈咧，更加容易可以喺入邊裝埋，喺入邊設計埋。其實就冇咩特別，即係冇咩創新嘅理念嘅。最緊要咧就係一路點樣做嗰陣時咧，點樣可以即係喺工程方面點樣可以做得更加好。
喺個過程裏邊，我哋收到好多嘅疑問信息咧，都係對於抽濕嗰方面，因為成個項目似乎抽濕呢樣嘢係好重要啦，打開咗好多嘅可能性。但係好多朋友都會問啦，如果要做到喺香港咁熱咁濕嘅環境，抽濕做到大概40%降到咁低，照計用嗰個電量係好高嘅。雖然降低咗濕度之後咧，亦都可以大即係提升咗舒適度，令到個溫度減少，就喺即係製冷嗰度可以慳翻。但係成條數有乜可能係可以慳到咁多咧？咁葉 Sir 可唔可以你帶咗都會可唔可以分享下一啲技術嘅細節俾大家聽？
其實就唔係話太難嘅，濕同埋熱咧呢兩個字一拼埋咧就真係解難搞喎。即係啲中醫都話濕熱啊，真係好難搞咁嘅意思。但係又其實就唔係嘅，因為咧抽濕嘅過程咧唔知你個量，你哋定義咗個量數會好大。其實如果你將佢一個 pressure positive 咗嘅時候咧，其實個量數唔大嘅話咧，其實涉及嘅能源嘅消耗咧都唔係咁多嘅。例如啲貨倉啊，同埋一啲住宅啊，咁其實佢即係能源咧損耗好少嘅啫。即係如果乾啲嘅話咧，用少啲冷氣咧，其實真係4兩搏千斤嘅。一個室內入邊咧，佢係唔會自己產生水分出嚟㗎嘛。咁點解會抽濕會咁難咧？咁就係因為嗰個壓力啦。原來咧，如果你係負壓嘅時候咧，佢猛咁走入嚟。咁如果你正壓嘅話咧，控制到少少正壓嘅話咧，佢走唔到入嚟嘅時候，你咪會慳咗好多能源咯。依家嗰個問題就係響呢個問題㗎。其實係壓力響我哋呢個空氣調節呢樣嘢係好重要嘅。始終都係要所謂叫壓力係控制得到，你個能源咧係同你係一個正比嘅。你控制到個壓力，你慳好多能源。就係咁。
其實一樣嘢我想補充，就正話阿葉 Sir 都講過，一啲貨倉啊，特別係嗰啲製藥、嗰啲 pharmaceutical 嗰啲 warehouse 啊，咁佢哋又為咗要控制濕度咧，裝一個好大型嘅冷氣個 plant 去 cool 24小時。對我哋嚟講，pharmaceutical plant 最重要就叫 humidity control， 佢哋完全係走錯方向嘅。如果佢引用我哋嘅 system 咧，佢 save energy 可以講緊80-90%，一啲都唔誇張。但係唔知點解冇人肯去行第一步。
啲米倉啊，先至最犀利嘅。啲米倉咧，其實最主要係濕度嘅啫，佢唔驚熱嘅。即係好似曼谷啊、泰國啊、馬來西亞嗰啲出米嘅地方，越南咧，其實佢哋咧個米倉咧最緊要就要乾。但係香港嘅處理咧係咁開冷氣幾百匹咁開，其實都對個地球都幾傷。呢個真係。
我哋廠度有個倉係1萬平方尺。嗰1萬平方尺咧，淨係用2部3/4匹嘅變頻機，OK， 總共1.5匹 ，OK， 係1萬尺地方。入邊最熱嗰陣時，外邊天氣最熱嗰陣時咧，入邊最高溫度大概27度度。喺入邊做嘢好舒服，唔需要其他冷氣。
濕度係保持住60%樓下，50%左右咯。